All right, welcome back everyone. We have 8.8, transforming tangent or the tangent function. Now your learning goal is to apply all the transformations to the tangent function. So we're talking the stretch and compress, the reflection, the phase shifts, the vertical shifts, the changing of the period, everything in one lesson to the tangent function. Okay, so let's introduce our tangent function. All right. Now, if you're looking here, everything looks very similar. Right? You have your A value for your stretch and your compression. You have your B value. You have your C value for the phase shift, and the B value does also change what the period is. And you have your D value for the vertical shift. Okay. So everything is looking very similar. So let's find out how this is going to be a little bit different. Let's just use a basic tangent function. F of x is equal to the tangent of x. So with no changes, just the parent tangent function. Okay. And let's make a kind of a sideways t-chart here. And let's start plugging in some values. We're going to do 5 values. So 1, 2, 3, 4, 5. Okay. Now, I kind of am going to lean us towards a certain set of values. We normally, when you're trying to work with a new function, you go with -2, -1, 0, 1, and 2 to kind of see. So let's put our 0 in the middle here. Obviously, we're not going to use -2 and -1, but we would use kind of the equivalent here, which is going to be, pi over 2, pi over 4, and, negative pi over 4 and negative pi over 2. Okay. So let's put that negative pi over 4, negative pi over 2, positive pi over 2, and excuse me, I did that wrong. There should be 4, and that's 2. Okay, so let's start with our middle value here, 0. Let's plug that into the tangent function and see what we get. Well, this is 0 degrees, but 0 radians because we're in radians here, right? So we go over there. We're at 0 radians in our unit circle. And if you remember, tangent is equal to the sine divided by the cosine. So here, sine is your y value, so that's 0. Cosine is your x value, so that's 1, so it's equal to 0. So no problem here, right? 0, 0. In fact, let's put some locations on our graph here. Okay. So we're at the point 0, 0. Let's put that in blue. Okay. Now we go to pi over 4. So we're here at pi over 4. Now that means you have to take square root of 2 divided by 2 divided by the square root of 2 divided by 2. So we write that out. Square root of 2 divided by 2 divided by square root of 2 divided by 2. You keep change flip. And if you notice, everything comes crossing out. Square root of 2 over 2 is 1. 2 over 2 is 1, so you get 1 over 1 or just 1. Okay. So let's put some values up here. Let's put a 1 here and a -1 there. So for positive pi over 4, we get a 1. All right. Now, if we go negative pi over 4, that brings us this direction to the same place. And it's very, very similar here, except for one of these values is negative. So instead of getting a positive 1, we get a -1. So instead of being up, we're going to be down about here. Okay, so if you only did this amount of points, it would look like you're doing like something like this. Okay, so we need to go a little bit further. We need to do negative pi over 2 and pi over 2. Okay, so we go to our graph, we go to radian of pi over 2. Well, all of a sudden that becomes 1 divided by 0. And 1 divided by 0 is undefined. And what that means for our graph is that at pi over 2, we have no value. So our function cannot be on that line. And then the same thing is going to happen when you go to the negative radians. You go down here, negative pi over 2, and it's the same thing. You just get -1 over 0, which again is going to be undefined. Okay. So what happens towards these ends here is it doesn't go like, just like this and stop. It's going to curve to that asymptote. So when I draw my line, it really is going to kind of go like this. Okay? It's really, it's going to make this flip in the middle and go up. Okay? Now, of course, I didn't write those answers up here. Let me put that in. We got 1 and -1, and we had, undefined and undefined. Okay? So we get this curve. All right? Now, this is very, very, very different. Okay? And if you keep following this, right, we keep going another, because this is going by pi over 4s, right? If we go again, and here we're just a little bit further at, 3 pi over 4. 3 pi should be in red. Okay, and then we're another, we keep this going a little bit further to, what's the next one? Pi, right? And then 5 pi over 4, and then 3 pi over 2. Well, think about this behavior here again. And if you're wondering, like, how the heck did you get those numbers? I was just, from pi over 2, I just kept going pi over 4. All right, so I got there, I got there, I got there, and I got there. Distance of pi. All right. This behavior is going to repeat itself. At 3 pi over 4, we get -1 because we have the same thing divided by the same thing. Okay, so just like we had a -1 over there, we have a -1 right here. At pi, we get 0 over -1, so we get 0. At 5 pi over 4, we get a negative over a negative, right? They're the same thing, so it returns to +1. At 3 pi over 2, well, we already know the answer to that because that was the same thing as -pi, right? So we know that's going to be undefined again. So we draw our undefined. Boom. And again, we have the same exact thing. And if you did this over here, you would get the same exact thing. I didn't really draw that one to scale, okay? But you're going to keep having this, and it's going to go on and on and on in both directions forever, okay? So this looks very, very, very different, okay? However, these A values, these B values, these C values, and these D values are pretty much going to do the same exact thing, except for one difference. Notice how, this is a periodic function. It repeats itself, but look at the distance of the repeat. From -pi over 2 to +pi over 2. That's a distance of 1 pi, right? From pi over 2 to 3 pi over 2. That is a distance of 1 pi. So our period is no longer default at 2 pi. Our period now is defaulted at 1 pi. So your new period formula is going to be pi divided by b, not 2 pi divided by b. But everything else is going to do the same thing, okay? So let's move into a Desmos exploration so we can quickly see how those things change our graph. Okay, so here we are in Desmos, right? You can see that we have our, let me switch this to projector mode here so it's just a little bit bigger. You could see how this tangent function is periodic, right? It is constantly repeating itself. And hopefully you could also see that we have our, our standard form plugged in, a times tangent of bx minus c plus d. Now, if you adjust the a value, you're going to see that it kind of looks like it's going up to a straight line, all right? Whoa, there we go. Yeah, we're going to get that negative value. And as you go between 0 and 1, you're going to see that changeover, kind of flatten out, all right? How does that exactly work? Well, think about, see if it's going to let me poke along it. Here we go. Let me get that. No, it's not really going to let me do it. So if you thought about the graph that we had where it went at 1 and -1 for the points in between, that's really going to be adjusted by your A value. If your A value is 5, that's most likely going to jump up to 5 and -5, okay? Now your B value is going to do the same thing. It's going to change the size of the period. I increase the B value, it makes it smaller, right? I lower the B value, it makes it bigger. And then, whoa, The negative is almost unaffected by it, but you can see that it does have, a flip there when you change that to a negative. But we probably won't be doing any negative b values. We generally avoid those, okay? So let's bring that back to 1. There we go. Now your c is going to do the same thing as your phase shift. You can see we're dancing there, right? Back and forth, right? If it's a positive, it looks like this positive number for c, which means that it's a minus c up top, moves it to the right. And then a negative, obviously, you're just going to flip that top to a positive. It goes to the left. And then finally, your d value, it's going to raise it up and raise it down, just like everything else, okay? So I hope this kind of helps you quickly see how you're going to do all these things. The real big difference between this one and all the other ones you've done is just that different size in the period. Okay, so here's what we're going to do, all right? I got 3 problems set aside. I'm going to do the first one off the bat. I'm going to ask you that if you feel comfortable to try the second one, and then I'm really going to want you to do the third one on your own before looking, okay? Now, we need to identify all the same things that we're used to identifying, okay? But remember, sometimes that d value, that vertical shift, goes in the front, okay? We look to the left of it, it's got no symbol, so it's positive, so our vertical shift is +2. Our a value is just a 1, right? Because there's nothing right here, all right? Now, we don't have a c value at all because there's no parentheses. We're not adding a c like that or doing anything there. But we do have a b value. It is 1/2 because theta is not included. It's our input, all right? So we have no phase shift, so I'll cross that out. We do have a period number of we have a b number of 1/2, which means we need to take pi and divide it by 1/2, okay? You take pi and you divide it by 1/2, you keep change flip, turns into multiplied by 2/1, or turns it into a period of 2 pi. Okay, so we did change our period there, all right? Okay. Now, what's different about this is when we go to graph this. As you saw, let's go back here, the period did not start here and go a distance of 1 pi. It kind of was half on each side. So when we say now that the period is 2 pi, it should go between negative pi and positive pi because that is a distance of 2 pi. So that's going to be a little bit tricky. But look inside, we still need to split it into 1, 2, 3, 4 segments, just like before, okay? So let's go back here. All right, we appear to 2 pi, so we'll have pi over here. We will have negative pi over here, okay? Now to split it into 4 chunks, well, the good news is halfway between those is 0, and so we really just need to split the left side and split the right side. Half of the distance between 0 and pi, luckily this time, is just pi over 2. And half the distance over here, luckily, is just negative pi over 2. Okay? Now, your ends here, where where it ends at negative pi and pi, those are your vertical asymptotes. Okay? Now, I know that we saw that it repeated this way and this way, but I really care that you just graph the one in between, because how many more do we really need to graph after that? Okay. Now, let's jump to a couple things here. All right, we're going to do this vertical shift last, so we're just going to graph a standard one. You can always assume that whatever your a value is going to be these points. So your first point to left and right, it's going to be at the negative one, and it's going to be at the positive one if your a value is positive. If your a value was negative, it would be the opposite. Your left one would be high and your right one would be low. Okay, so we got a point at 0, 0. We got a point at pi over 2 and 1, and then negative pi over 2 and negative 1. And we don't really need to draw the rest of the points because it's just going to be, oops, come on. It's just going to be curving. Let me use a different color. Curving to it. Okay. Now, that's not the end here because we saw that it had a vertical shift of +2. So we're just going to add 2 to all. So 2, 1 plus 2 is 3, right? So this point's going to be all the way up here. We had 2 to 0, so it's going to be here. We had 2 to negative 1, and so that's going to be here. And so our real function, we can still kind of start it all the way down, and it's going to cross. What? I just got erased. Let's just do it like this so it looks better. Okay. So, the vertical, the one that I just shifted, the shapes don't look the same, but they should be the same. Okay. And that's it for this one. It's the same thing you've been doing. It's just a little bit different. Okay. Now, if you feel comfortable, try this one. All right. And note that we do have a negative a, right? We do have a c value this time. If you're not comfortable taking those on, then just watch. So pause and try if you're ready. Don't pause if you're not. Okay, so if you did pause, I hope you got it. We have a -1 as our a value. And, just a quick comment here. It's not actually an amplitude for tangent, because tangent doesn't operate like a wave. And that amplitude is supposed to be for wave. So it's just an a value, and it really just represents a stretch or a compression or shrink, however you want to call it. Okay? Now, your period should be pi divided by b. And in this case, we look at our input, which is x here. So it's 1/2. So it's pi divided by 1/2, which again, we just did that. That gives us a period of 2 pi. Okay? We have a phase shift. It is still c divided by b. C is pi/2. So pi/2 divided by 1/2. Or we flip it, right? 2/1, the 2's cancel. And so we have a phase shift of pi. Now this is a negative, right? And so this should be moving to the right, okay? So pi to the right, okay. Now we have a -3 for our vertical shift, so we should go down 3 at the very end of things. Now you saw in the last one, when we had 2 pi, that it straddled 0, right? We were half on this side, and we were half on this side. But if we phase shift everything over to the right, 1 pi will now be at 0 and over at 2 pi, kind of like our sine and cosine functions. So we're going to do that off the bat instead of writing out all those other numbers. So we know that we'll have our vertical asymptote here because it moved over pi, and I'm going to have another vertical asymptote over here, which will now be at 2 pi. I'm going to split it into 4 chunks, pi, pi/2, and 3 pi/2. Now, if you're confused at what I did, remember that they should have been originally at -pi and pi/2, but we moved them over a pi because of that phase shift, okay? And, that puts us at 0 and 2 pi, okay? And that works because our period is 2 pi. So we're going from 0 to 2 pi. We're still honoring that period. Everything else is moved over, okay? Now, we're going to graph what we have, and then we're going to worry about this vertical shift. Now, of course, the ones we've been doing before, right, we go based off that amplitude number, which the real number is just 1. In fact, I should have just wrote this as 1. We don't include the negative. The negative is for the reflection, but the a value is still technically just 1. I know that gets confusing. And when we graph this, what we would have done is we would have done like, let me put the -1, +1. We would have done this. We would have put a point here, here, and here if it was a positive, a. But because it's negative, it flips. It's now here, here, and here. So instead of going low and high, we're going high, and now we're going low. Okay, so let me put those points in. We're going to have it at, let me do a different color, 0, okay? +1 on the left now, -1 on the right now. We're starting high, crossing over to go low, okay? So that's that flip there. When, we have that reflection, if it was up here now, it did flip to be down there for that start, okay? So everything did flip, all right, over that x-axis. Now we vertically shift it by a -3, so all of these are going to go down. So -1, let's make a -2. I need a -3. Wow, a -4. I should have prepared for that. Okay, and so this value here is going to go 1, 2, 3 down and be here, and so is the rest of them. So that'll be here. It was at 0, now it'll be at -3. It was at +1, now it'll be at -2, and so it'll look like that. It's okay that it's kind of getting cut off by the screen. Okay. And that's it. You don't have to graph it over and over and over again to the left and right. We're really just caring about that very, very first period here. Just like we did with sine and cosine, we really only graphed them over a single period, even though we could have kept going. All right? Now, I want you guys to try this one. I want you to try this one on your own first. Okay? Note that it does have a different number for A. Make sure you adjust for that. So I want you guys to give this one a pause and a try. Okay, so you would have gotten an A value of 3. And now our period is going to be pi divided by B, which is 2. And that's it. Pi over 2 is our period. So it is going to kind of get shorter, going to get closer together. Our phase shift is still C divided by B, so that's pi over 4 divided by 2 over 1, or really, that's just pi over 4 times 1 over 2, which becomes pi over 8 as your phase shift. Your vertical shift doesn't exist. It's 0. There is no vertical shift. Okay? So, we got a lot of stuff going on here. We're going to have to adjust that period. All right? It's got to be pi over 2 now. So, before... let's actually go back here to, I think it's good to look at, let's look at this one. Before we had a period of, let's look at one where we had a period of 1 pi. So here, this was a period of 1 pi. It went from here to here, from pi over 2 to negative pi over 2. Now we have a period of pi over 2. So we're going to be half that distance at negative pi over 4 and pi over 4. You add those two together, that is a distance of pi over 2. Okay? So let's go back here. And let's write that in. Okay? We're going to have an edge. And we could still make it a little bit wider so it's easier for us to draw this, of pi over 4 and negative pi over 4. Okay? Now if you're confused, how on earth is this guy getting these values? You really think about it, it's just half of the period, right? Because if you want half of the period on the right, you want half the period on the left, okay? Now we did have a phase shift of pi over 8. Now this is a plus, so that means it needs to go to the left pi over 8, okay? And this part's going to be fairly tricky here because that means we have to, go just a little bit this way and go a little bit this way. And we're going to have to do the math here. Okay, so pi over 4 minus pi over 8. Okay, we convert this to have the same thing, so that would be the same thing as saying 2 pi over 8 minus pi over 8. Okay, which is just pi over 8. So now we're over here at pi over 8. Okay, which means we need to do the same thing for this one. So negative pi over 4 minus pi over 8. We just saw that pi over 4 is the same thing as 2 pi over 8. Whoa, pencil down. Okay, almost made it the whole video. All right, so this would be negative 2 pi over 8 minus pi over 8, which is also negative 3 pi over 8. So now we're over here as our edge. So we're going to go like this. And then we're going to go like this. Okay. Now, we do need to split this into multiple parts here. Okay, we do have this pi over 2 period. That's good. Okay. But thinking about because in this one, where are we on this one? You could just easily split it, right? Like what's half of 2 pi? Well, half of 2 pi is just pi. That's easy to think about, right? But when we're here and we're like, what is half this distance? Well, think about it. We're moving by, pi over 8s here, right? So going from pi over 4 to pi over 8 was a distance of pi over 8. Going from pi over 8 to 0 is a distance of pi over 8. And then going from 0 to negative pi over 8 is a distance of 0. And then going from negative pi over 8 to negative pi over 4 is a distance of pi over 8. So really we're going to use 0 and we're going to use negative pi over 8. Now if this confuses you, right, then my suggestion would be to write these with the denominator of 8. Because if you write in with the denominator 8, you'll see that this is just negative 2 pi over 8. And then look, the negative 3, negative 2, negative 1, 0, 1. It becomes very, oh my gosh, I almost lost pencil again. It becomes very easy to see that that's just, we're moving in those perfectly divided sections. Okay? All right, let's fill this in. Okay, so we have an amplitude of 3. So that means we are going to go all the way up to 3. So 1, 2, 3, and down to negative 1, negative 2, and negative 3. We start at the center at 0. Let's do a different color. We start right in our center there on the y-axis, and we're going to go to the amplitude, or the a value, because it's not amplitude, on the right and the left of that. So pi over 3, negative 3. I'm sorry, I said pi over 3. To 3 and to negative 3. Okay. Now, we just have to draw the rest. There is no vertical shift, so it's going to kind of just be like that. All right? And that's it. Okay, now this problem was much more difficult. One of the more advanced problems, and it just comes down because of these numbers here, right? That's what's going to make some of these problems kind of tough, okay? All right, that's all I got for you guys. I hope you enjoy this. I'm sorry it's late, and I'll see you guys next time.